So thanks for inviting me to speak today. I'm going to talk about a project that we have actually finished at this point, and some of the ETL work that went into this project. And so this was the University of Colorado, the Anschutz Medical Campus. We were involved in one of the earlier kind of FDA BEST projects. And you've all heard about this project because George Ripsack presented a few weeks ago about some work that he is leading and involving the OHDSI network in. And before that, Columbia, Regenstrief, and the University of Colorado were involved in some earlier work. And I wanted to talk about some of our ETL work, and because this was very interesting and took a lot of collaboration and a lot of effort. And I liked Alison's slide, which said like 80% of the effort was like getting the data right. The analysis after that can be somewhat easy. So the task that we were assigned, and we came into this work 1 year later than the other partners, so we had a little bit of catching up to do. But in addition to be a member of the data network and be able to do queries across the network, we had to have our data in the OMOP CDM, and we had to participate in data quality assessments, and then we had to answer surveillance queries and do analytics. The work that we were most focused on during this period was actually looking at adverse events for blood product transfusions. And this included TRALI, so transfusion-related lung injury, and then TACO, or transfusion-associated circulatory overload. And these reactions are serious but fairly rare, particularly TRALI. So they can be hard to detect in EMR, and there may not be many cases in any one setting. So it really does take a network to begin to kind of untangle maybe some of the, just to be able to identify these things, develop ways to identify TRALI, and then also assess kind of predictors for TRALI. But where we started here was really thinking about, okay, well, where's the data, right? And, you can see the package of packed red blood cells, right? And so this is what we were looking for. We wanted to know who got what. And right underneath that barcode is a number, kind of letter combination, begins with the letter E, and that's the ISBT code for the product. And there are over 9 pages of ISBT codes. I've got a screenshot of just page 1, but there are over 9 pages of these codes. And the complexities in kind of finding this blood transfusion information is that, well, one, many more kind of blood products, not just packed red blood cells, but all blood products, they're prepared and ordered much more than they're ever transfused, right? So we order more than we need because we're not quite sure, and these are usually given in pretty, extreme kind of serious conditions. There are both, in most of our EHRs, there's both an order prepare that might go to goes to a blood bank that would prepare the order, and there's an order transfuse, and these are all often kind of created at the same time, but acted upon kind of at different times and for different reasons. Again, we prepare more than we transfuse. The documentation varies as to how we know whether someone actually got the blood product or not. And then there has to be an integration between the EHR and the blood bank data. So when we looked at this, we really had to go back to the beginning, and we had to look at the orders and say, okay, well, how's the order get initiated? Where does the order go? So the order prepared generally goes to the blood bank. Then it's issued, the blood product is issued, so that means it's released from the blood bank and is usually kind of sent to nursing staff or the setting where the transfusion is going to occur. It could be the ED, it might be an operating room. And then there's an order transfused for when a transfusion is given, so when the blood product is administered, although there's not always an order transfused. So again, some of this depends on the scenario that the care is occurring in. So I'm not going to read every word on this slide, but a little bit about kind of what I had just said. So on the last bullet, the thing that was kind of key for us in this, and that SafeTrace was our blood bank, and we found data stored in a number of places within the Epic Clarity kind of Beaker lab tables, which is very helpful for us. And then Epic Caboodle is the source for our OMOP data transfer. So we needed to know where this data landed in Caboodle, and we needed to make sure that it was actually in Caboodle so that we could do the Caboodle to OMOP ETL. So just in reference to the various kind of scenarios and different types of documentation I referred to, a few things to point out. There are occurrences where there are massive emergent transfusion protocols that are initiated. And you could think of this as a traumatic event, someone coming into the ED or someone bleeding kind of, severely and urgently, where the protocol is really just an order for this massive emergent transfusion. And multiple blood products, multiple quantities of the blood products desired are actually prepared and sent to the area that they are needed. At this point, the transfusion orders are really not done. They're just given as rapidly as they can be given to save this person's life. So we don't have the same type of documentation on that kind of order transfuse. The other thing is that in the operating room and during and with anesthesiologists in the anesthesiologist record, they don't write an order transfuse either. The anesthesiologist is there to kind of support the patient's care, both for pain control and stability during the operative procedure. And if they think someone needs this, they have it on hand and they give it, but they don't write themselves an order to do what they know needs to be done. Now, they do record these in anesthesia records, but just to show you that this information kind of exists in different places, depending on the setting that it's given. And then plasma exchanges were a whole another thing, often done in a different setting and with different documentation. So one of the things that was key was that we really had to look at this. I felt like we were really triangulating, I guess, different sources of data. So we're looking, at Clarity and trying to figure out where data is there. We're looking at Caboodle, which is, Epic's data warehouse, and the one, again, that we ETL to OMOP. And then we're actually looking in hyperspace, too, which is where physicians, nurses, care team members actually enter data and where we could review data and kind of be able to figure out where the information we needed was best recorded. So this is information that is coming from laboratory source, and this is you can see here that we have the date and time under the issue date, and that was information that we needed. We had the status. So was it transfused or was it ready? Because again, if more is prepared than transfused, we can't go by what was prepared or what was kind of issued and sent to the floor or the OR. We also have blood product description as far as the ISBT code. And then you can see there's other information that might be useful, including below, you can see the number of units. Now things look a little bit different. We couldn't find that same type of information when we were looking for information that occurred from the OR or from even the ICU potentially. So here's an OR flow sheet, and you can see the products that are administered, and you can see their volume, and that's time kind of across the y-axis with the date. And that is all useful, but what we didn't have was an ATBS ISBT code to really help us identify exactly what type of product was transfused. And for those of you that know this, or into this, I mean, even packed red blood cells, I mean, whether they're leukapheresed or apheresed, there's all these different ways of preparing these products that are really key and important to kind of understanding whether people have reactions. So it's much more than just kind of platelets or much more than just RBCs. Then further below, but in the same, you can see the ICU. So now in the red circle is the ISBT code. So again, now we're getting a little bit more information than we were getting in the OR. And then at the bottom example is an ED flow sheet. And here we don't have, again, we've got time, but we're missing the ISBT code. And we really did need those things. So since Caboodle was our source, we also went to Caboodle, and we kind of scoped out, well, what's the information we need and where do we get what we need, right? So originally, we really wanted to have a start date for the transfusion, but that could only be found in this blood product administration fact, which is actually the name of one of the flow sheets, and it's the flow sheet that the nurses use usually on the floor when they're administering a product. And that did have the ISBT code. The lab component result fact sheet had the code and had the issue time, and that information was coming from the lab. And so it was very discrete and also coming from the blood bank. There was an integration there because we also had the statics. So that was coming from some of, if people are familiar with EPIC, from the beaker tables. And then there were two other places that we found some information, but without the ISBT code, it really wasn't of much value to us. And, we had a lot of debates about, do we combine information from these two tables, or where should we, where's the best place to get this information? So we also went back and we took our blood bank report and we took a time period where we had complete information, and this was 2017. It's actually not easy to query the blood bank database. You can't go in and just do SQL queries and manipulate and get what you want. You can get some preset reports, or you have to make a special request, like to the folks that kind of have developed the blood bank that might be able to do something for you. But so you have to pretty much use what you have. So what we did is we took counts of what we had from the blood bank from 2017, and then we aligned that with the counts that we got from these other tables. And you can see that that blood product administration fact flow sheet really, did pretty poorly for packed red blood cells, a little bit better for platelets. But where we had the best information was really the information coming from the lab component result fact sheet. And I'm going to go back one slide, because what this meant then is that we had the issue time, but we didn't have the start time. And initially, for the work that we were doing with the FDA, they really wanted us to have the end time, because they wanted to know when blood product administrations had ended, because a lot of the kind of queries that they wanted to do to see if there had been an adverse event were supposed to occur within the time period after the transfusion ended. But that information was even less well recorded. We can imagine that, when a transfusion starts, there's actually a human in the room starting the transfusion, and they record that start time. When a transfusion ends, there may be no one around, until 20 minutes later, 30 minutes later, depending on what's going on the floor. But there doesn't need to be a human at the time it ends, right? The pump it's finished, and it can sit there for a while. So, so what we did is we really ended up focusing on that issue time, because that was the most kind of comprehensive and complete data that we had. So just to kind of wrap this up as far as our takeaways, I mean, we really felt that, to do this well, to make sure that we were getting the right data from our EHR, from our blood bank, because there's really two sources that are involved in this. It's going from the blood bank into the EHR, combining with EHR data. We really needed some deep subject matter expertise, and we had to talk to people who knew kind of what was happening on the floor, in the OR, in the ED, at the blood bank. We had to really triangulate this investigation. We really had to look at both the EHR front end and talk to people at the front end, and we had to look at the back end and investigate both of those. And then, it was really important to validate against the blood bank database. There was no way we would have known that we were missing so many transfusions if we hadn't done that work. So that's what I've got for you today.